Hello everyone. Got some old boys on the bench today. These are some of the oldest systems from the Franklin eWaste haul. And these all look to be mid-1980s, early 1990s. And some of these systems have some serious weight to them, so I am dying to know what's inside. They're also from some pretty unknown manufacturers, which I've never heard of, except NEC, of course. Alright, well, let's tear into these. Alright, the first system we're going to be looking at is this absolute behemoth of an AT clone. It's manufactured by a company called ARC, or American Research Corporation. I can't find a whole lot of information on that company, but that could be due to the fact that those are some pretty generic search terms. We can see it's a 286 turbo, so we'll see if that's true. Got our key lock here, and hard drive activity and power LEDs. Got our 5 1/4 inch floppy drive here. Left side of the machine has the gigantic IBM style toggle switch for power. Ultra satisfying. See, we got some damage here, unfortunately. And having a look around the back, we've got a manufacturer sticker here. Model number AT-286. Oddly enough, no serial number or product code, but we do have an FCC ID here. And here's a closer look at that label. And the power supply has a voltage selector switch. Now, if you don't know, this switch is critically important. It absolutely must be set to the correct voltage for your mains input. Unless, of course, you want to see a power supply fireworks show. Not quite sure what's going on here. This might be some kind of like reset switch that they rigged up. See, of course, we have our AT keyboard connector. And I don't know how well you can see that, but that looks like one of those notoriously explodey batteries. So we're going to have to check that out when we take it apart. And here's our graphics card. Looks like it's an EGA/VGA card. Got our standard serial and parallel ports here, and a dial-up modem. Looks like this case opens up just like any other IBM PC, XT, or AT system. Got 5 screws in the back here, 2 on each side and 1 in the middle. Looks like the one in the middle is the only one that's still present. So let's go ahead and open this thing up. And once all those screws are out, the outer cover just slides forward. And oh man, this thing is a beast. We've got a full-length MFM drive controller card here. The MFM hard drive is unfortunately missing. Looks like that dial-up modem is also a full-length card. And there's our graphics card here. And of course our serial and parallel port card. And oh yeah, that battery definitely did some damage. And it looks like that switch on the back is a reset switch. You can see it's wired to the reset line there. Alright, let's get this disk drive out of here. This thing's kind of just floating in there. Though it does have some rails, that's interesting. A little bit dusty, but overall pretty clean. Spindle motor's not stuck. And look at that, there's an ARC sticker on there. Really can't find much information about that company. I would love to know more about them. Alright, let's go ahead and get these cables out of here. Looks like this thing had 2 MFM drives at some point. Let's go ahead and disconnect that power supply from the motherboard. And I'll disconnect that reset switch. Well, actually, that's soldered on there. Either soldered on or wire wrapped. Oh, it was wire wrapped. Let's disconnect that hard drive LED. And let's check out this MFM card. Let's see how badly that corrosion got the edge connector. Okay, it's not too bad. I'll definitely be able to clean that up. And it is a Western Digital card. Looks like the newest date stamp on these chips is 1985. And here's a good look at that chipset. And not too bad on this side of the edge connector either. I'll definitely be able to clean these up. Alright, let's check out that graphics card. And it's a Trident card. TVGA 8800CS. Here's a good look at those chips. And check out this old school transistor here. Oh, that thing is cool. And here's a look at the back side of the board. Looks like this edge connector also escaped the worst of the corrosion. I'll definitely be able to clean that up. Let's put that to the side. Now let's check out that serial card. And yep, it's a serial card. Looks like we got a date stamp in 1985. Made in USA. Edge connector is definitely salvageable. And here's a look at the back side. Alright, let's check out that gigantic dial-up modem. I haven't seen a dial-up modem this long in a very long time. Looks like it's a Natural Microsystems Corp, model Watson 2, date stamp 1986. And here's a look at the backside. Alright, let's get this motherboard out of here and see how bad the damage is. Start by disconnecting the PC speaker and the key lock and power LED. And check this out, it's got a protective cover on the back side of the board. Well, it got some rust on the inside of the case, but it doesn't look too terrible. And this machine is actually a 386, so it's had some upgrades. Got no math coprocessor, and we got no RAM. So hopefully this thing has some onboard RAM, because I definitely do not have any of these types of SIM modules. And the BIOS is split across 2 ROMs. I believe that was done as a cost-cutting measure because 2 8-bit ROMs were cheaper than 1 16-bit ROM. And here's the damage, at least on the top side of the board. So let's go ahead and get that battery cut out of there. Okay, well so far it doesn't look too terrible, but the real story is going to be on the underside of the board. So let's check that out. Alright, let's get these standoffs out of here so I can get that protective cover off. And it looks like it's just glued in place, so just carefully pull that off. Okay, well here's the underside of the board beneath the battery, and honestly, not too bad. And wow, this could be one of the most repair-friendly motherboards I have ever seen. They've got all the component values just printed right on the silkscreen there. And that is absolutely amazing. I won't have to do any kind of hunting down of schematics or anything. Look at this, they even went through the trouble of printing out the power supply voltages. They even give you the part numbers for the major ICs. Why can't all motherboards be like this? Okay, now we gotta neutralize the electrolyte. And all I'm going to use for that is some white vinegar mixed with distilled water at about 20% concentration. Now I'll give that a few minutes to work its magic, then I'll do the same thing for the underside of the board. Alright, now I'll get these BIOS chips out of here. And all these pins look good. And all those pins look good too. Now I'll extract the keyboard BIOS. And these pins got some corrosion, but luckily they didn't get eaten. Now let's get that oscillator out of there. Let's get some vinegar in that socket. I might possibly have to replace this crystal, but luckily, this board being as amazing as it is, gives you the value right there. 16 megahertz. Same deal for this crystal up here. I think I'm falling in love with this motherboard. Okay, well as far as trace damage goes, it's not too bad. It looks like the solder mask took the worst of it. Scratched off a little bit here to see how badly it got the copper, and yeah, it's not too bad. Now one of the things you have to consider is, when this type of corrosion happens, it thins out the copper traces and that reduces their current carrying capacity. So if they get too thin, you have to shore them up. You can do that by just tinning them up with some solder, or by laying a thin piece of wire on top of them. And the only broken trace I found so far is this one directly beneath the battery, but that'll be a really easy fix. And the 40-pin dip socket for the keyboard BIOS did take some corrosion, so I'm just going to go ahead and replace it. No point in trying to clean it out. I'm going to do my best to show you my desoldering process, but it's not very easy with the camera in the way. I'm just going to lay a bead of flux across those pins. Now I'll take my desoldering alloy and just melt it into each one of these connectors. The desoldering alloy has a much lower melting temperature than regular solder, so it mixes in and dilutes the existing solder, thus lowering its melting temperature and making removal much easier. It also seems to work out really well on this corrosion hardened solder. And there we go. Now let's get that bottom side of the board cleaned up. Now let's get some flux on the top side of the board. Then I'll clean it up with the desoldering wick. And you're probably wondering why I don't just use one of those vacuum desoldering pumps. And the answer is, I just simply don't have one. Hadn't really been able to justify buying one, because my method works perfectly fine. Now let's clean up that flux. Now I'll do the same thing for the other side of the board. Alright, now we can get that new socket soldered in. I like to just slightly roll over some of the pins so that it stays in place, and then solder them on. Now let's clean up that flux. Now I'll just clean up the pins on the keyboard BIOS chip with a fiberglass scratch pen. Alright, that's clean enough. Let's just get that back in there. Alright, now I gotta fix up these traces I exposed, and for that I'm gonna use some UV curable solder mask. Now I'll spread it around. Now I'll just put it under my UV light for a while to cure. Alright, that's cured up now. I'll probably do a second coat. Hardest part about using this stuff is getting an even coat on the first try. You can see we're kind of thin in certain spots, but second coat will fix that right up. Okay, so now I got to take off this keyboard connector and possibly some of these ISA slots. I'm also just going to replace all these pin headers. Alright, got that first slot off. Now I have been having the worst luck sourcing replacement ISA slots. Seems like the thing to do is to try to remove them from scrap motherboards, but we don't really scrap motherboards around these parts. So, it's experiment time. So I'm gonna see what nasty old CLR can do for them. Now that stuff is crazy caustic, so obviously you don't want to get it anywhere near a circuit board. But since we have the slot removed, I want to see if it can clean this thing up. Just go ahead and put that in there. Oh, look at that, it's foaming up in there. Foaming up like a rabid dog. Okay, well actually that worked really well. That thing looks brand new. It's probably hard to tell on camera, but I can't see any hint of green whatsoever left. Okay, so maybe this is a viable alternative to replacing the slots, since I'd have to desolder them anyway. Okay, so we might as well see what it can do for the keyboard connector. Okay, well the keyboard connector didn't turn out too bad. At least the contacts inside are no longer green. And here's why you don't want to use CLR on the board. See, it's actually etched the copper. Okay, well, I guess I better get started on the rest of these. Well, that took forever. Okay, so I'm actually not even going to bother repairing this trace, because it only concerns the barrel battery. I'm just going to use this external battery connector. And I've already got a new pin header soldered on there. Alright, now I'm just going to hit these BIOS sockets with deoxit. And then get those chips back in there. Alright, now it's time to freshen up these edge connectors with a fiberglass scratch pen. Alright, that's much better. Now I just have to do the other side, and do the same thing for the rest of the cards. Alright, let's see what kind of demons are haunting this power supply. I don't have many power supplies in this form factor, so I'm going to take this thing apart and check it out before we smoke test it. And that is a lot of spider activity. Apparently this was also the spider's nursery. It's a lot of egg sacs. Sure hope Mama Spider's long gone. Okay, nothing inside looks like it's in imminent danger of exploding. I do like the way this thing comes apart though. You guys get a front row seat to any explosions that are gonna happen. Alright, sacrificial hard drives are connected. Got the voltmeters voltmetering. Let's see. Alright. That thing works. And that fan bearing sounds great. Alright, I'm going to give this thing about 5 minutes. That should be plenty of time for any explosions to happen. Okay, well, 5 minutes later, no trouble at all. Let's go ahead and shut this thing down. Alright, gave that thing just a quick de-dusting. So now I can finally get this thing back together and see what this system does. Okay, let's see what our new friend CLR can do about that giant rust stain. Just got some of that on some steel wool here. Okay, well that's a lot better than it was, and that only took about 5 minutes of work. That was a lot easier than my other plan, which was to break out the sandblaster. Alright, got the motherboard back in there. Also got the disk controller card and the video card in to minimize complaints. Let's see what it does. Well, I don't know if you saw that, but we just had a tantalum cap let the magic smoke out. Specifically, that tantalum cap. Okay, well luckily this board gives us the value right on the board there. However, I don't have any of these on hand, so that might be as far as we're getting with this system. And we are short on the 5-volt rail. Okay, well, I guess I need to start checking for that every time I see tantalum caps. Guess this motherboard's making it to the motherboard repair video after all. I better get some tantalum caps ordered. Okay, well, let's turn our attention to the disk drive and go ahead and pop that cover off and clean those heads. Not too bad. And here's a good shot of the label on the rear of that drive. And to test this drive, I'm going to enlist the help of the Baby AT486. But before we can do that, I need to remove this terminating resistor block. And that's because of the way I have to configure the cable. The terminating resistor block should only be on the drive that's at the end of the floppy cable. And I gotta put this one in the middle. Alright, let's see what this thing does. Power on. And we got a seek. Alright, got a disk in there. Let's see if it reads. And it does. Very nice. But let's see if it writes. And it writes. Alright, that drive works. Okay, well, let's see if it'll read a high density disk. And indeed it does. Alright, well, that's good enough for me. Okay, well, a little bit of heartache out of this system, but tantalum caps are ordered. But for now, let's move on to the next system. Alright, the next system is this absolute behemoth. I'm dying to know what's inside this thing because it weighs about 50 pounds, or about 23 kilograms. See, it's branded as CenturyNet, which I've never heard of before. Got this big old toggle switch on the front for power. Got our 5¼ inch drive and a very funky looking 3½ inch drive. And this panel here actually flips down and for some reason or another has a volume control. I can't imagine it's for anything other than the PC speaker. We've got our key lock here and we got a little spec sheet here. Looks like there's a pretty good chance we might have a hard drive in here. That would definitely explain the weight. And having a look around the back, of course, we have our AT keyboard port. We have not one but two serial and parallel port cards. Got a dial-up modem here. And here's the graphics card. Now, one problem is I don't have a CGA or EGA monitor. I only have one that might fit the bill, but it's kind of sketchy and untested. We've already had one smoke show on this video. Maybe we'll get two. And I'm not sure if that's composite or RF output. Okay, now I have to figure out how to open this thing because I do not see any screws. I think this back panel must pull off. Okay, there we go. Okay, luckily that came off in one piece. And we got another sticker. Made in West Germany. And we got another sticker up here. And here's a better shot of those I/O cards. Alright, let's go ahead and open this thing up. Boy, this thing is really fighting me. It does not want to open up. I know this has to slide forward. Okay, I think at this point it lifts off. There we go. Wow, look at the size of that hard drive. Let me get you guys a better camera angle. Oh yeah, we definitely found the source of the weight. That is a full-height Maxtor MFM hard drive. Oh man, I cannot wait to hear that baby sing. I want to go ahead and pull that thing out right now. Let's get that power cable out of there. Let's get these MFM connectors off. Alright, got to remove this screen. Oh, let's not lose that. Now this should slide forward. Oh, we got a ground connection back here. Get that disconnected. Oh man, this thing is a beast. I really hope this thing works because these things sound glorious. Here's a look at the side there, and here's a look at the back. See, we've got a capacity of a whopping 85 megabytes. And in case you've never seen a full height hard drive before, here it is compared to a regular old 3½ inch IDE drive. Just absolutely dwarfs it. And here's a little bit of hard drive history for you. These older drives always had defects, so the manufacturer would do defect testing. And this is a list of all the bad sectors on the drive. And that's just how it was back then. So when you were shopping for a hard drive, you would try to find the one with the least amount of defects on the label. Alright, I cannot wait to hear this thing spin up, so I'm gonna go ahead and power it up, and I'm gonna put the microphone next to it, because you have got to hear these things. Okay, well, sounds like the stepper motor is sticking. Kinda no surprise. Sounds like a Rage Against the Machine song. And here's a look at the logic board. I'm gonna go ahead and pull that off and see if I can access the stepper motor. Let's go ahead and get that bracket off of there. Let's get this insulating thing out of here. And we have no access to the stepper motor, so we're gonna have to pop the lid. Okay, well, I think I found all the secret screws, so let's see. The seal is broken. Actually, looks like this is some kind of early voice coil design. I thought this thing must have had a stepper motor driven head. Alright, so that's why it sounded so much different than I remember. Man, look at those chips on that flex cable. Okay, well, after letting the drive operate for a few minutes, it does sound a bit better. Now, I have never seen a full height hard drive with a voice coil head, so I actually have no idea what they're supposed to sound like. Every other full height MFM drive I've ever encountered used a stepper motor to control the head. So let's continue on with the rest of the system. Maybe this thing will behave better when it's plugged into its controller. Alright, we're in luck. This thing has an external battery pack. And it hasn't exploded. And that is no ordinary motherboard. That's actually an ISA backplane. And it looks like this is the system card. Wow, I've actually never seen anything like this in person before. So let's start by removing that card. Let's go ahead and unplug that battery. So I'm pretty sure it's dead anyway. Let's just get it out of there. Just go ahead and disconnect the front panel connectors. And then let's unplug whatever this is. And there it is. So for all intents and purposes, this is the motherboard. You can see we have an AMD 286. Looks like we have two 8-bit BIOS ROMs. And there's the system RAM. And here's the CPU. And that's cool. How often do you see an AMD chip with an Intel copyright on it? And here's the back side of the board. Let's put that in the safe spot. Now let's take a look at that graphics card. Looks like an Emulex card. The year of 1986. So far everything in this system is really clean. Alright, let's check out another ginormous dial-up modem. Wow, look at that speaker on this thing. Look at the size of that chip. See, we've got a bunch of AMD chips on here. Looks like the newest date stamp is on that BIOS with 1984. So this is a pretty early dial-up modem. It looks like there's another one of those giant chips underneath the speaker there. Here's a look at the back side of the board. Alright, let's check out that serial and parallel port card. Pretty standard looking. Another super clean card. Just got to clean up the edge connector. Alright, let's check out that disk controller. Let's get these MFM and floppy cables disconnected. And then disconnect the hard drive LED. Looks like a Western Digital board from 1985. Yet another super clean card. Well, I figured out what was rattling around in there. A thumbtack. Alright, let's go ahead and get that power supply disconnected from everything. And let's go ahead and give it a test. Alright, sacrificial hard drive's ready to go. We've already had one smoke show in this video. Let's see if there's two. Nope, fired right up. Sounds like that fan's choking on something. Look, we see sparks. Something blew up in there. And that's why we test them. Okay, well, it's not immediately apparent what arced, but just based on the smell of it, I think it was one of these transformers. It did cause the fuse to blow, so this power supply might be salvageable, but that'll be a project for later. This system takes standard AT power, so I'll just grab a random AT power supply and test it with that. Well, it sucks to lose a power supply with this form factor, but I should be able to fix it. That'll be a project for later though. Alright, let's check out these disk drives. And the 5 1/4 inch drive is a TAC drive. And there's the model number here. Pretty nice drive. Spindle's not stuck. And pretty clean considering. Alright, let's check out the other one. Now that's a weird one. This is the 3 1/2 inch drive. Looks like it's also a TAC drive. And there's the model number. Spindle motor's not stuck. Let's go ahead and clean these up a little bit. Okay, I went ahead and liberated that 3 1/2 inch drive from its little enclosure and got the top cover off. And it's a good thing I did because this thing is filthy. Let me just sweep that dust off with an anti-static brush. At least what I can see. I'm not going to go full teardown on this thing just yet. Now let's clean up those heads. Pretty clean. And the 5 1/4 inch drive is simple enough. It doesn't even have a top cover. That's pretty clean also. And yeah, this time I am checking for shorted tantalums first. And we are good. And just to make sure I have continuity to ground. Yep, we're good. Okay, since I don't have any EGA monitors, I'm going to have to use this Trident ISA VGA card. So let's go ahead and get this, the system board, and the disk controller card back in and see what this thing does. Alright, went ahead and treated all those ISA slots with deoxit. Also cleaned up all the edge connectors on the cards. So let's get them back in. Okay, well, one small problem. We've got a short on the 5-volt rail, which I traced back to the disk controller card, and it's got a bunch of tantalums on it. So for right now, I'm just going to leave this card out until I can figure out where that short is coming from. Alright, here we go. Power on. Oh look, we're counting RAM. Yeah, check it out. That thing's counting RAM. Okay, complain about the keyboard. Obviously I don't have one connected. Looks like this thing wants to boot. Alright, now I gotta figure out what's wrong with that disk controller card. Okay, well, it looks like in this case the tantalums are innocent. I removed 2 of them from the 5-volt rail, and we still have what might be a short. It's not a dead short. It's showing 14 ohms, so maybe that's normal for this card? We might just have to risk it. Okay, so I checked the disk controller from the previous system, since it has a very similar set of chips, and it also has a crazy low resistance on the 5-volt rail, so that might just be normal for these cards. So I decided to risk it. If this thing blows up, blame sugary snack foods. Here we go. And don't mind that rattling, it's just the power supply fan. And it's posting, and it's counting RAM. So I guess that disk controller card is fine. And we got post beeps this time. I actually forgot to turn that little volume control up last time. Alright, well, I guess let's get some drives connected. I really hope that power supply's got enough oomph to power that giant hard drive, because I really want to see if that thing actually works. Alright, got a double density IBM DOS boot disk, courtesy of the PS1. So, let's see if it boots. Okay, well, access the drives. Go on. Sounds like it's booting. Yeah, check it out. That thing booted. Awesome. So that drive works. I'm pretty sure that 3 1/2 inch drive is double density, and I don't have any double density 3 1/2 inch floppy disks, so I may not be able to test it. However, I know what I can test. Let's get this monster back in there. Alright, let's see if that power supply explodes. Okay, yeah, I don't think that hard drive is any good. That makes me incredibly sad. Yeah, all it's doing is its best Tom Morello impression. Alright, well, I tried a few things off camera, like playing with the drive type settings in the BIOS, and I even replaced a couple of the capacitors on the board, but still no luck. Now, it's entirely possible that this drive is not matched to that MFM card. MFM and RLL drives have to be used with the controller card that formatted them, and there's no guarantee that that's the same card. I didn't get into trying to low-level format it. That might be all it needs. Maybe track 0 is just corrupted or something. But this is not the last you'll be seeing of this drive. Well, even though that 3.5-inch drive is a 720K drive, should still be able to format a high density disk. So let's find out. Alright, well, it's formatting. Alright. I think that was successful. Yep. Okay, well, let's see if we can copy a file to it. Alright, that drive works. So both of those TAC drives are survivors. Okay, well, despite some power supply pyrotechnics and a troubled hard drive, this machine's perfectly fine. And I know it doesn't convey on the video, but this case is so rock solid. The case alone is most of the weight of this thing. And I just cannot get over that volume control for the PC speaker. I'm definitely going to be doing something with this case. Don't know if I'll keep that 286 motherboard in there. But for now, let's move on to the next system. Alright, next system is this NEC PowerMate 286 Plus. So you've got PS2 keyboard and mouse ports right in the front there. And this thing looks awfully familiar. I'm pretty sure I had one of these when I was a kid. Got our 5.25 and 3.5-inch floppy drives. And we kinda sorta have a turbo LED here, though there is no turbo switch. Pretty sure there's a keyboard combo to toggle turbo mode. And having a look around the back, it has everything you need on board. Got our parallel port and serial port, and our VGA port. Got a dial-up modem here, and we got 5 screws at the back here. There's also 2 screws on each side. So let's go ahead and get those out and get this thing opened up. Alright, now the outer shell just slides back, and then lifts off. Alright, this thing has a hard drive, and it's an MFM drive. And I see several other amazing goodies, so let me go ahead and get you a better camera angle. And there's our MFM hard drive there, but I see something even more amazing. Check that thing out. That is an adapter board to convert a 286 into a 486. And on top of that, it's a Texas Instruments 486. I'm trying really hard to contain my childish excitement. I'm actually just going to leave that in there for right now. Alright, let's get these MFM cables out of here. And we got lucky again with the battery. This one also uses one of those battery packs. Pull that out of there. And the drive controller is a Western Digital card, made in 1988. Hey, just like me. Let's go ahead and pull that hard drive LED and get that card out of there. Here's a good look at that chipset. And here's a look at the back side of that card. And there's the dial-up modem. It's another one of those gigantic speakers on it. That's so that you can really hear the AOL busy signals. Got a copyright date in 1989. Let's get that out of there. And here's a look at the back. And check that out, we got a RAM expansion card. Let's just ever so carefully pull those. Ah, I didn't even barely touch that and it broke. Okay, you know what? On second thought, I think I'll just leave those SIM modules in there. Let me get that piece. Maybe I'll be able to fix it. Okay, well, let's pull that card out of there. And there under that SIM module, you can see it's an AccuLogic. Guessing that's RAMP AT or RAMPAT, however you pronounce that. And here's a good look at that card. And here's a look at the back. Alright, let's check out that motherboard. Looks like we got an onboard Paradise VGA chipset. Alright, let's get this hard drive out of here. That fan bearing feels great. And this drive is an NEC D3142. That's gotta be original to the system. And it's a stepper motor drive. So I might finally get to hear a stepper motor hard drive for the first time in 28 years. And we got a date stamp of December 1989. And here's another sticker on the side. I don't see anywhere that indicates the capacity of the drive, but I cannot wait any longer to hear this thing. I gotta spin this thing up. Okay, well, it sounds like it initialized. That's a good sign. Let's go ahead and shut it down. Alright, let's get these floppy drives disconnected. And let's get that cable out of there. And that is most definitely a non-standard power supply connector. So I got my fingers and toes crossed that that power supply is good. Let's go ahead and disconnect it for now. And that's interesting, it only has one Molex connector. The other two come in the form of this cable here that connects to the motherboard. Alright, now let's get these floppy drives out of here. And it looks like these are retained by clips behind the faceplate, so I'm gonna have to pull that off and hope nothing breaks. Alright, ever so carefully. Alright, that went well. Now let's get rid of these retaining clips. Now that drive should just pull right out of there. It's a pretty clean drive. Spindle motor feels good. And it's an NEC FD1157C with a date stamp of 1990. Now that 3.5-inch drive doesn't have any clips holding it in. Let's just pull it out. And it's also an NEC drive, FD1137H, also made in 1990. Not much to see on the bottom. Alright, let's clean up the heads on that 5.25-inch drive. And I'll do the same for the 3.5-inch drive. This drive's kind of weird. It has a PCB on the top of it. And everything on this system is just really easy to work on. Like I had this entire drive almost completely taken apart in less than a minute. Alright, let's get that power supply out of there. Alright, with all the screws out, looks like it just pulls forward. Yep. And lifts out, maybe. Seems like that power switch is interfering. Push that in. That's some tight clearances. But it's out of there. This power supply has some kind of access panel here. Let's see what's under that. What the? That's weird. I thought it would give you access to like the circuit board or some fuses or something. Guess it's just a channel for some wiring. That's weird. Let's get that out of there. Alright, I want to get this power supply completely apart so that if something does explode, we can at least see what. Let's snip them zip ties. Pretty clean little power supply inside. So we might have some reefer caps that might let the smoke out, but we'll see. And I can't run this power supply for too long because it does not have an internal fan. It depends on airflow from the system fan. Alright, got the Lone Soldier sacrificial hard drive on our single Molex connector. So let's see what it does. Okay, so we're a little high on the 5-volt rail and a little low on the 12-volt rail. But with the load of a single hard drive, I kind of expect the voltages to be a little wacky. I'm just going to let this thing run for a little bit and monitor its temperature, see what it does. Okay, I think that's long enough. Got our factory spec zip ties back in place. Alright, got the drives reinstalled. Faceplate went back on with no smoke whatsoever. So, time to test this thing out. Alright, let's just see what it does with nothing attached. Power on. Oh, it's posting. Yeah, check it out. Looks like it wants to boot. Alright, let's get that hard drive back in there. So this is funny. A modern keyboard connector won't fit. The squareness of the top interferes with that round hole. So I'm just going to cut this down with a razor. There we go. Like a glove. Did the same thing for the mouse connector. Alright, I just went ahead and reinstalled everything, including that RAM expansion card. Let's see what it does. And it's counting the RAM. Counting the extended RAM. Alright, let's run setup. Okay. How do I run setup? Might be a separate program you have to run to get into the setup of this BIOS. Okay, yeah, according to a Vogons thread, you do need a special setup utility for this BIOS. So, hopefully this floppy drive works. Let's also test the 3.5-inch drive, why not? Alright, retry boot. Alright, looks like it booted. Now let's see if the B drive works. And looks like it does. Okay, I'm not even sure which one of these utilities to use. I'm guessing HS286_12 means 12 megahertz. So let's try that one. Sector not found. Well, you know what? Let's try copying those over to the A drive. Nope. Well, let's try formatting that disk. Okay. It's formatting a 3.5-inch floppy disk with 360K. This thing's awfully confused. Okay, well, it was successful. Now the question is my Windows 10 machine going to read this disk? Let's go see. Okay, yeah, my modern system wanted nothing to do with that disk. So I used my trusty PS1 to copy those files to the 5.25-inch boot disk. So, let's try running that again. Sure hope I have enough disk space for extracting all these files. Okay, so I guess we just run setup. Ah, this. As foretold by the Vogons post. Okay, maybe set hardware configuration. Okay, well, one little problem. That drive doesn't have any parameters written on it at all. And there's 47 drives to choose from. Alright, gotta go try to find some info on that drive. That's funny. I exited the setup utility and it turned my DOS shell inverted. That is funny. Okay, this segment's getting kind of long, so I'm gonna figure this out off camera. Alright, I was able to find the parameters of that drive by googling the model number, and I got everything else set, so let's see if we brick this thing. Okay. Let's get the boot disk out of there. Nope, hard drive's doing... Oh, it's booting! Yeah, that hard drive works! Awesome! Let's see what this thing has on here. Oop. So excited I can't type. Oh, it's got Keen on it. Let's see what Keen this is. Keen 1. You know, I gotta play that. Well, I don't have PC speaker sounds, but it is playing. Let's see, maybe that's a setting. Nope, guess not. Oh well. I can't believe that hard drive works. What version of DOS is this even? DOS 5. Let's see if it has scan disk on it. Nope. Let's see what else we have. Oh, it's got Keen 4 on it. Of course I'm going to try to play that. Ah, never mind. It's not on there. Let's see what's in util. Got pkware. Alright, let's see what's in the DOS folder. Of course I'm going to try to play Nibbles. Oh, there's some PC speaker sound. Go easy on me. It's been almost 30 years. Sure. We are color. Yeah, it's working. Alright. Now I'll see if I can remember how to get out of this. Okay. Ah, I think you have to reboot. How do I not remember this? Let's see if Sammy finishes dying. Maybe it'll kick me out. Nope. Apparently Sammy has infinite lives. Gotta reboot. Well, let's run check disk on it. Alright, it's 44 megabyte drive. Now the problem is when I shut this thing down, I'm going to lose all those CMOS settings, so I'm going to have to rig up a battery. Alright, so this is going to be real ghetto, but it's just temporary until I find a properly cromulent battery. Since the original battery pack is 6 volts, I just took two CR2032s and put them in series, and I confirmed that this motherboard does not attempt to recharge the battery, so I don't need to put any diodes or anything on there. And yeah, we're at 6 volts, well, a little bit higher than 6 volts, but it'll be fine. So I'm just going to shmoo these two batteries together and stick it in there. Yeah, janky, I know, but it'll do for now. Let's see if it's got Windows on here. Sounds like it does. Yeah, it's got Windows 3.1. Listen to that hard drive. Windows 3.1. It's got Visual Basic on here. Might have been a programmer's computer. It's got an ancient version of Office. Yeah, it does. Let's open up Word. Wow, I've never used this version of Word before. This disk is about full. Well, that was fun. Alright, I couldn't be happier with how this thing turned out. It's a 486 dressed as a 286, has a working MFM hard drive, and it's a dream to work on. I think I love this system. Yeah, this one's definitely a keeper. Let's move on to the next system. Okay, next up is this Zeos branded system. I guess that's pronounced Zeos. Now that company actually has a wiki page, and looks like they went belly up in 1995. You can see it's badged as a 486, so we'll see if that's true. Got our turbo button here. Have we finally found a system with a functioning turbo button? It's got a creative CD burner. Now that's very interesting. Got a regular old Memorex CD drive here, and of course 3.5-inch floppy drive. Alright, this thing's got all kinds of crazy ports and peripheral cards. Got our 9 and 25 pin serial ports here. Got a parallel port, and of course it's an AT system. Got our video card with all kinds of display output options. Looks like we got a mouse card or a breakout I/O shield, one or the other. Got another printer port. Got our dial-up modem here. Looks like it might be a 56K modem. And a USB card? That's odd to see on a 486. Starting to suspect some upgrades. And we got a very interesting looking sound card. It's got the volume knob right there. Here's a good look at that sticker. See, it allegedly has a 486 DX2, so we'll see. Now I'm guessing this back panel pulls off because I don't see any screws. Yeah, looks like it does. There we go. Alright, let's get this thing apart and see what's going on in there. Alright, got all those screws out. It looks like this case slides backwards. Yeah, there we go. And then lifts off. Oh yeah, this thing's been upgraded. That is definitely a socket 7 CPU. That bearing feels very loose. Well, let's see what kind of CPU that is. And it is an AMD K62, looks like 400 megahertz, no thermal pad or thermal paste. That thing must have been screaming hot. Oh no, my warranty. Well, that's really stuck on there. Who puts a warranty sticker on a CPU? Come on. Alright, let's pull that thing out of there. And yep, AMD K62, 400 megahertz. Pins look good. The socket's got the little temperature sensor underneath, spring loaded to stay in contact with the CPU. Just get that back in there. Alright, I'm going to pull this heatsink off and give that fan some love. Alright, the fan is oiled and cleaned up, so let's get it back on. Let's at least give this thing some thermal grease. Give it a fighting chance. So let's go ahead and get this cable out of here. Alright, let's check out that sound card. It's an analog devices card and has an OPL3 chip. Very nice. Let's see what board model this is. Model MF009. Never heard of that, but hey, at least it has a real OPL chip. Let's put that in a safe spot. Alright, let's get these breakout shields out of the way so I can look at that video card. And it's an ATI card. Looks like a Rage 128 AGP card with the Rage Theater chip on it. Yep, ATI Rage 128 Pro. The date stamp for the year 2000. Let's put that to the side. Alright, let's find out why they were using an IDE card on a board with onboard IDE. Oh, that's why. It's a Promise Ultra 100. These usually gave much better performance than the onboard IDE controllers. And there's a look at the back. Let's check out our dial-up modem. It's an 8-bit ISA card, year stamp in 1996. Now I'm assuming based on this sticker that it might be a 56K modem. And the USB ports are just a breakout shield to the motherboard. Alright, let's check out that RAM. That's a lot of chips. Looks like 512 megabytes, PC 133. Check out the other one. No clear indication of size or speed on this one. Let's check out the last one. This is a 64 megabyte PC 100 stick. So you can mix and match PC 133 and PC 100. It just causes the PC 133 stick to downclock itself. Not the most ideal situation, but it'll work. Alright, let's get all these edge connectors cleaned up. This motherboard also accepts 72-pin SIM modules. And there's a good look at the BIOS. And here's a good look at the motherboard chipset. Alright, let's get that CMOS battery replaced. A little bit of shmoo in there, so let's just clean it out. So let's get the new one in there. And that power connector is in a very awkward spot. Okay, that wasn't too bad. Wow, this motherboard's really just floating in there. Gonna have to get some screws in that. Alright, let's get these drives disconnected. Definitely not as easy as a tower system to work on. Got all kinds of cables stuffed up here. Just gonna leave that IDE cable in there. Alright, let's go ahead and test that power supply. See, it has extra surge. Let's see if it has extra smoke. This power supply looks just as old as the case, so I won't be surprised if it explodes. But let's see. Alright, got a bit of wonkiness on the 12-volt rail. Alright, 5 minutes later, everything's fine. Now the system does not have a hard drive, but it has plenty of space for them. Got a 3.5-inch drive bay here, and two 5.25-inch drive bays here. Could stick a full-height hard drive in there if you wanted. I don't know what else you would do with it because there's no access to it through the front panel. Alright, let's take a look at those CD drives. The Memorex is a 48-speed drive. The manufacture date of March 1999. And the Creative CD Burner has a manufacture date of November 1999. And both drives are ATAPI IDE drives. Alright, time for a power on test. Got no RAM in there, so let's see if it complains. Power on. Alright. We are complaining. That CPU fan sounds great. Alright, let's throw some RAM and the video card in there. See what this thing does. Alright, got all the RAM and the video card in there. Let's see what it does. And it's posting. Showing 98 megs of RAM? That's definitely not right. I'm going to try dropping it down to just that 512 stick. Okay, so maybe this system doesn't like PC 133. I'm not quite sure why that was in there, or how it was working, if it was working. Okay. Let's get that back out of there. Alright, got that PC 133 stick out of there. Also reconnected both CD drives and the floppy drive. Got a DOS boot disk in there, so let's see what happens. Alright, both IDE drives are detected. Let's continue. Alright, it's booting. And got both CD drives initialized. Sweet. Well, let's just see if they open. Alright, that one's good. How about the creative drive? Nope, that one's gonna need some help. Oh, there it goes. Guess it just needs some exercise. Let's see if it'll read. Let's see if that one got assigned R drive. And it reads. What was that? I've never heard Dura make sounds before. What on earth was that? Okay, that was weird. Alright, let's try the creative drive. I love how lazily slow that opens. Alright, spun up, so let's see. And it works! Awesome! Got two working CD drives. Now this machine should support a ATAPI boot, so let's see if it runs Knoppix. Now with this being a 586 machine, I had to reach into the past and get this old copy of Knoppix. Alright, we're not configured to boot from CD, so let's fix that. Save changes and exit. There we go. And we got an ACPI error, but that's because we're using AT power. And we're not going to have enough memory to start KDE. Oh well. That's weird. Every time it reads the CD drive, it gets a little bit of noise on the screen. Could be because that motherboard's still floating, so it's not exactly grounded properly. Alright, let's see what GLX Gears does. Okay, that's running very weird. Usually that means 3D acceleration's not working. Yeah, anytime you get these crazy high frame rates from GLX Gears, it means software rendering. And that's kind of no surprise. This was back in the day when ATI seemed to absolutely hate Linux. There was no good support for ATI cards at all for 3D acceleration. Alright, let's kill that. Alright, well I didn't hear the Knoppix startup sound, so let's see if it even detected that sound card. Nope. Alright, gonna have to find another way to test that sound card. Alright, let's go ahead and get a hard drive in this thing. And this is the perfect use case for my gigantic quantum Bigfoot. It's that 8GB drive, and it's one of the few components from my childhood that I still have. And last time I tested it, it still works, so we're gonna see. First, let's get this drive cage out of here. Alright, got that in there. And if you're wondering why there's only 3 screws in this drive, it's because there's one broken off in there. Gee, wonder who did that. This also gives me a chance to test that Promise Ultra 100 IDE card. Alright, here we go. Power on. Alright, the Bigfoot initialized, but it's not detected. Oh, there it goes. Oh wow, this thing still has an ancient install of Arch Linux on it. Well, let's see if that boots. Apparently not. I couldn't tell you when I installed that, probably around 2004, 2005. Alright, well, let's get a DOS boot disk in there. Alright, we're gonna have to do some partition work on that thing. Let's delete whatever's on there. Delete that one, yes of course. Let's delete all of those. Alright, now let's create a new one. Yes, I do. Alright. Huh, I guess it's the CD driver making that sound. That's interesting. Alright, now we should be able to format the C drive. Looks like we're only getting 2 GB, but that's perfectly fine for a test. Alright, that looks successful. Let's create a label. Alright, now I'm gonna have to wipe grub off the MBR. I think that was fdisk/MBR. Okay, I think that worked. Now I want to copy everything on that floppy disk over to the C drive. That way I don't have to hunt down and reconfigure all my CD drivers. Alright, now let's make C drive bootable. Alright, let's try to boot to that hard drive. Let's get that disk out of there. Alright, we got DOS on the hard drive. Well, unfortunately, my reasoning for doing all of that just went out the window because I cannot find the DOS driver for that sound card. But you know what, for the specs of this system, it's definitely more appropriate to put something like Windows 98 or maybe even Windows XP on it. Overall though, I'm more than happy with how it turned out. And this case is really stout, so I will definitely be doing more with this system. Alright, I am determined to get this boy working. I did try to low-level format it, but the drive wasn't having it. So if you know of any diagnostics or common faults for these drives, please let me know in the comments. And as always, I'd like to express my eternal gratitude to everyone who's subscribed and pledged their support on Patreon. Thank you so much for your continued support in helping this channel to grow. And if you're new to the channel and this is your thing, be sure to subscribe, because there's a lot more coming. But that's all for this video. Thanks for watching.